All right, we're recording. Hello, everyone. Unit 7 review. I hope you like my hat. Shout out Miss Moon for getting me a hat with the ice cream logo, the ice cream container that you get at like Dairy Queen and stuff, with my Blue Jays logo on it. Um, you can probably tell that I'm stalling right now. Seems that either it's been a while for me or that why can't I share my screen? Yes, I can. They changed the buttons a little bit here with Zoom. So let's see where we're going to allow. I need to share my desktop. Let's get rid of all this stuff. And there we go. All right, now we're cooking. And okay, that's the problem we did in class. Okay, Unit 7 review. Let's get to it. Oh my gosh, whenever I record myself, I just, feel so bad for your generation. I'm so self-conscious about how I look on this video right now, and that's how you guys feel all the time with all the recording. Heart goes out. So anyway, um, it's not your fault, but it is your problem. So stop recording yourself. Okay, right here we're looking at standard form, but this is that weird type where standard and vertex form are actually the same because we have no B value. It ends up being standard and vertex are the same. Usually the answer there is going to be standard though. We have factored form here, also known as intercept sometimes, because it makes it easy to find our x-intercepts. Whereas standard form, which this one is right here, makes it really easy to see what our y-intercept is. And then our vertex form, this one is this vertex here. This gives me the vertex, right? I can tell right now that this is going to be a vertex of 3, because that's the opposite here, and 3, and it'll be 3 times as steep as usual. Vertex form is my favorite, I think. Right here, we have another factored form, aka intercept, and standard. Okay, hopefully all those things were pretty easy because admittedly, it's getting tougher after that one. It's a good warm up. All right, we got to figure out where the best place to put this bar is. Can I hide this? No, I'm afraid if I hide the video panel, I don't know. I'll just move it, I guess. All right, let's move it over. Okay. Rewrite in standard form. So basically, this is asking for me to use a box. If you FOIL, good for you. I cannot stay organized with FOIL. So I use the box, but it really does the same thing where you do x times x with FOIL. X times x is right here, which is x squared. Or you would do in FOIL, you would go right there to get x times 13. Since we're showing FOIL at the same time, let's go down here. So x times 13, 13x. First outside, then inside last. So x times -1, that's -1x. And shout out Miss Wolford who loves FOIL. She has much better handwriting than me. All this stuff gets blended together if I don't use the box method. I see my like terms there. I have x squared plus 12x because 13 minus 1 is 12. And then that -13 is just sitting there at the end. That standard form makes it very easy for me to see what my y-intercept is. Ooh, almost missed it there. It's a -13, not a +13. My x-intercepts, let's put them in a different color here. To find those, x minus 1 equals 0. X equals 1. So my first x-intercept would be 1, 0, or the first one that I found anyway. Let's do the next one. X plus 13 equals 0. Why am I equaling 0? Because we're trying this this form gives us our intercepts, or a way to find our intercepts. Where are all of your x-intercepts? They're on the x-axis. And if you're on the x-axis, your y value is 0, right? Maybe I'll put that in there. Your y is equal to 0. You're just finding the x values. So you've got quite a bit here uh, to build off of. So the axis of symmetry, how I found the axis of symmetry, I actually used my calculator and I looked, hey, where is this symmetry happening? You can also, use that formula, negative b over 2a that we've done before. So negative 12 over 2, a is 1. So I can just say, hey, what's negative 12 divided by 2? Negative 6. So my axis of symmetry, x equals negative 6. I'll admit here, for finding my vertex and my axis of symmetry, I used my calculator, went into the calculator, saw where my symmetry was happening, and put it in there. But you can just put negative 6 into this standard form function. You can also put it into the intercept form function, but I think we're more familiar with doing this, and that should have given you negative 49. We have a positive a, so we are facing up. We're going up, up, up. This is our moment. Unit 7 gonna be golden. Oh my gosh. Remember that song? Remember when it was cool? Maybe it still is. Okay. Speaking of being cool, I'm going to turn my hat around backwards and go over the top of this parabola. If you don't know what that's a reference to, Google backwards hats over the top and arm wrestling, and you'll see the greatest movie of all time. It's called Over the Top, by the way. All right, so what is the y-intercept? The y-intercept, that's right here, right? It's 0, 0. What does it mean in this context? It means that the ball starts, right? 0 seconds. It starts by bouncing off the ground. Okay, it's not being dropped from a height. It's not being, or we're not measuring it. If it is, we're not measuring until we boom, hit the ground. You threw it on the ground. All right, the maximum height of the ball. This is where you can just look at your graph, see that your maximum height is happening at 16 feet. How did I find that? I'm using my vertex here. My vertex is 116. That would be when it's happened in 1 second. So that 116 means that in 1 second, it will be 16 feet in the ground. When does the ball hit the ground again? There's my solution, my x-intercept. It hits in 2 seconds. Makes sense that if it's at its peak in 1 second, it will then be on the ground again in that another second. 1 plus 1 is 2. Don't say you never learned anything from me. Okay, x plus 9 equals 0. Solve that. X equals negative 9. X minus 4 equals 0. Solve that. X equals 4. So my two zeros are my intercepts. I can write them like that, or you can say negative 9, 0. Or 4, 0. But Mr. Cunningham, can't I just put the opposite of the numbers and not have to do the work? Well, I guess in those one-step ones, it wouldn't hurt you, but then you get here and you're like, oh no, what's the opposite of 2x plus 4? And that's where the solving will come in handy. Okay. because you are solving. I know I'm going fast. Rewind, go slow and solve that equation. You got x equals -2. I don't think I could eyeball that one. I would have to actually solve it to see what that is. I might be able to eyeball this one, but hey, just in case you can't, 3 minus x equals 0. Add x to both sides. You got 3 equals x. So x equals 3. Again, that could be written as -2, 0, as well as 3, 0. Onward. All right, rewrite in standard form. Again, I'm a box method kind of guy. X squared, 3x, -x. Remember, you're multiplying on the outside. Maybe it'll help if we write -1x. Multiplying on the outside, but then when we combine these like terms, 3 minus 1 gives me +2x. You're adding on the outside. All right, so my y-intercept, I can tell, is 0, -3. My x-intercepts, I am going to eyeball those ones because they're both one step. X plus 3 is a factor, so -3, 0. It's going to be an x-intercept. -1 means I'm going to have +1, 0. So I already have 3 very important points on this graph. I have 0, -3 as my y-intercept. I have -3, 0, which gets reflected over onto the other side, and 1, 0 reflected over what, you might ask? Well, the axis of symmetry, that is. -b, so -2 over 2a. -2 divided by 2 is -1. And let's just look here. If I have zeros at -3 and 1 and +1, the middle of that, let's do the axis of symmetry. X equals -1. The axis of symmetry, I'll draw it here, is at -1. Okay, so my zeros are both on the equal side of it. So you could have maybe even just gone to the middle of those zeros and said, hey, that's where my axis of symmetry is going to be. The vertex that creates when x was -1, make it blue so that it can, was -4, by the way. Okay, so I have a point here. It gets reflected across the y, or the axis of symmetry, right? So now I have some very important points here. These should be exact on your test, right? If you wanted to do one more, 1, 2, 3, 4, 5, just to make your teachers smile with your upward parabola. You could. All right, onward. Alrighty. Oh no, let's clear that little dot there. Go. All right, rewrite in standard form. So if we're rewriting this in standard form, we need to realize that x minus 2 squared is saying x minus 2 times x minus 2. And then you'll -4 from whatever you get from the box. Ooh, that's a sloppy Punnett square there. Okay, so we've got x squared, combine -2 and -2 to get -4. X plus 4. Don't forget about that -4 at the end. 4 and 4 are going to combine to get rid of each other, essentially, in this case. So we have x squared minus 4x, which means that my y-intercept is actually 0, 0. Okay. My axis of symmetry. Okay. If you wanted to do negative b over 2a, so negative, the opposite of b, negative 4 is our b, so we would have positive 4 over 2 this time. 4 divided by 2 is 2. So my axis of symmetry is at x equals 2. Plug that into your equation, and that'll give you a vertex of 2, negative 4, 2, negative 1, 2, 3, 4. And speaking of what we were talking about before, even without knowing what my other 0 is, I don't have factored form here. But if I have 1 0 that is 2 spaces away on the left of the axis of symmetry, that means the other 0 is going to be 2 spaces away on the right of the axis of symmetry. I happen to know that these points go there too. So now I have a nice, pretty parabola, okay, which is facing up. Okay. All right, find the time where the rock hits the ground. If we're modeling here, basically, what is this question asking? It's asking if you had a parabola, right? Like if this is going to be modeled with this, we're trying to find out where the zeros are, right? So we need to know where the rock hits the ground. That's just asking you to find zeros. So 27 plus 2.7t equals 0. Solve that. Minus 27, 2.7t equals negative 27. Divide both sides by 2.7. And you get time equals negative 10. There should be a red flag going off in your head. It's like negative 10. So we're going to go back in time 10 seconds. No, we're not going to do that. So that one doesn't really make sense. Okay. The one that does make sense, 3 minus t equals 0. Add t to both sides. And you have a time of 3 seconds. When does the rock hit the ground? It doesn't hit the ground back in time 10 seconds. We're going to say, okay, when we're modeling this with a parabola, the solution that actually makes sense if we were to draw this would be 3 seconds. Right? So if we rewrite the function in standard form, so again, use our box method here. I like having, let's draw it a little bigger. I don't like the order of these. I would rather 2.7t be first and then 27 be there, and then negative t plus 3. So you end up with negative 2.7 t squared. Sorry, this pen is kind of melding right here. Negative 27t. The only reason this is fast for me, I did it before, right? I have my work worked out there, but 3 times 2.7, you get 8.1t. So if you need to slow down, do that. 3 times 27, you have 81. So why did we do all this? Now we have negative 2.7t squared. Negative 27 plus 8.1 gives us negative 18.99t plus 81. The whole point of this was to find how high the rock was when it was initially dropped. That is just asking our y-intercept, which we would say our y-intercept, 0.81, so we would say it's 81 feet when dropped. Okay, so if we're looking at, like if we're putting this on a grid, right? We're looking at this rock being dropped here. It's going to be modeled with a parabola. And like we said before, this -10 back here, that doesn't really help us for the context of the problem, right? It doesn't help us to know that -10 we'd be at 0. What helps us is to know that after 3 seconds, we hit the ground. It also helps us to know that this is dropped from our y-intercept at 81 feet. Okay. So this is using all those things you know about parabolas to help you in a real problem. This here is great. All right, let's turn it back around. We won an arm wrestling match, so we're going to turn it back around. Calm it down a bit. All right, now we're talking about a soccer ball here. So find the time the soccer ball hits the ground. Okay, well, we have two factors here, -16t equals 0, and we have t minus 4 equals 0. If we solve that, 0 divided by anything is 0. Solve this other side, and we have 4. Okay, when did the soccer ball hit the ground? Okay, let's look at what this just told us about the soccer ball. T equals 0. So we have a y-intercept and a x-intercept that are the same thing. 0, 0 means the ball is going to be kicked from the ground. And 4, 0 tells us that that's when the ball is going to hit the ground. Okay, write the function modeling height in standard form. So again, I wouldn't use the box actually with just one thing that I have to distribute, -16t times t, -16t squared. Just distribute, I think, but it's up to you. Plus 64t. So again, this tells me I have a y-intercept and an x-intercept. See, there's no y-intercept here. I already knew that from the x-intercept of 0, right? But this confirms I'm going to be kicking the ball from the ground. How long does it take the ball to reach maximum height? Okay, we could do -b, -64, over 2a, 2 times -16, which gives us -64 divided by -32, which gives us 2 seconds. Well, when is that going to be? Why would we, what am I trying to say here? Okay. We used our math here to figure out that, hey, this is our axis of symmetry. In 2 seconds, this is when we're going to reach our maximum height. Another way that we could have figured that out, if the ball is on the ground at 0 seconds, on the ground in 4 seconds, halfway through those is when the ball is going to be at its maximum height. Plug 2 into that equation, and you get that the height is 64, right? So -16 times 2 squared plus 64 times 2 gives us 64. So that means that the height of the ball in 2 seconds is 64 feet. All right, almost done. Okay, again, when I'm just distributing one thing, I probably don't use the whole box method. 2x times x, 2x squared. Just knowing that, you should be able to find your answer by now, but we'll do it why did I say 6? Plus 3x. We'll go the long way, so that matched with letter B. This next one, again, on all of these, once you get that first box figured out, the answer becomes obvious, but let's just practice and make sure that we're good at this stuff. Okay, so this matched 6x squared, -18 minus 2 minus 20x plus 6. That matched with A. X minus 1 squared, don't be fooled by these. This means that you're saying x minus 1 times x minus 1. x squared minus x plus 1. There's only one option that even looks like this, so I know this might be redundant at this point, but the more practice, especially on these ones where the numbers aren't 1, the more practice, the better. So 3x minus 4, 4x plus 3, we got 12x squared minus 16x and plus 9x, negative 12 there. So this ends up being matching D, which was 12x squared minus 7x minus 12. All right, study up, check your work, all those good things. Bye.